Hi, my name is Laurie Baker. I'm very pleased to be presenting at latinR 2022. Today, I'm going to be talking about designing and teaching community-engaged data science. So a little bit about me. I'm a professor of computer science at College of the Atlantic in Bar Harbor, Maine. I'm also a certified RStudio instructor, and my background is in marine biology and disease ecology, and I've also worked as a data scientist. In the last few years, I've taught data science to undergraduates and also civil servants in the UK and internationally. And you can follow me on the web, my personal website, or on Twitter or GitHub to see some of the research and education projects I work on. So today, what I'm going to be discussing is the course Community Engaged Data Science, which is a course I taught this past year at Bates College. I'm going to talk a little bit about where this course might fall into a wider data science curriculum. I'm also going to cover the course goals and the learning objectives and different aspects of the course design, as well as advice and lessons learned. So the audience for this talk is educators who teach statistics and data science using R, who are interested in integrating real-world project experience into their courses, and also in connecting with partners in their communities. So the motivation for this course is that I think that we teach the data science workflow extremely well in a lot of our data science courses, where we walk students through importing a data set, tidying it, carrying out exploratory data analysis, where we transform, visualize, and model our data, and then we also communicate this. But I think that where some of these courses fall short is that we often are missing the audience member, and we're also missing the community partner and collaborators that we're doing this work in partnership with. And these collaborators can be extremely important in adding to our analysis, including asking the questions like, who else should be involved in this work? What are the limitations of the data beyond those that we can see sort of on initial glance at a data set? What is the research question and project goal? How is this going to be used in a community setting? What additional information is needed? So exposing students to multiple ways of knowing and different sort of knowledge sources. Understanding like, what do the findings mean in real terms? Are they going to be useful? Can they inform a policy decision or shed light on an issue that we care about? And then also, what are the limitations of the analysis and what are future next steps? And working with individuals that are close to a data question and an issue can be really important, and is something that I believe should be integrated into more of our classes. So this curriculum builds on two courses that I teach at College of the Atlantic. So I teach a course in visualization and also in analysis. And both of these courses do a good job of exposing students to research methods and also technical skills. So they learn about reproducibility, they're exposed to qualitative and quantitative research methods and experimental design. They're also gaining technical skills in R programming, data visualization, version control using GitHub, as well as other data science libraries, and coding standards and practice. And where this course, Community Engaged Data Science, sets in as it is an advanced level course that gives students a more complete picture of what it means to be a data scientist out in the real world. And so students gain skills in professional skills and also collaboration skills. So networking, project management, working with stakeholders, engaging with stakeholders, communicating to audiences outside of the university, and also a more in-depth look at sort of what teamwork looks like when you're working on a data science team. And then they're also getting to apply and develop their contextual knowledge. So understanding how their backgrounds, affect the conclusions that they draw about data, understanding issues in social and environmental justice, developing a more of an appreciation for a domain knowledge, and also looking at the ethical implications of a project as well. So the course goals broadly for community engaged data science were to work with community partners on a jointly defined research project of benefit to the wider Maine community, which is the state in which I live, and to gain insight from data, building skills in reproducible analysis and collaboration, working on a real data science problem using R and GitHub, and to build skills in teamwork and project management, applying techniques used by data science teams like agile methodologies that are designed to foster co-development and also iterative and incremental project delivery. The prior knowledge that this assumes is that students are experienced with R, they're experienced with ggplot2 and tidyverse. They are familiar with R Markdown and GitHub. They might have had some exposure to more advanced data visualization techniques like our Shiny and Leaflet, and that they also have experience with analysis. So working with linear regression, maybe some machine learning, maybe some text analysis, although these skills are more or less important depending on the type of project that they'll be working on. And so they're already familiar at this point with the data science workflow and taking a data set and moving it through to a final report. But they haven't had as much experience applying this knowledge to real world problems yet. So I taught this course as a 1-month intensive where students were just working on this particular course. I'm adapting it now to work for a 10 to 12 week trimester. And there's more information about the course than I can go into on within this 15-minute presentation. So I would invite you to check out the course website where there's a lot more detail on each of the steps that I'm going to introduce. In terms of course size, I think that this advanced level course works well for a smaller class size, so maybe up to 20 students. This means like 5 research projects and 4 students per team. And this is manageable with 1 instructor. I think as you have more instructors, you could scale it up. There's several sort of different steps. So one is pre-course, which is partner and also project selection. Weeks 1 to 2, students are spending on the project planning and scoping. So getting more familiar with the project that they'll be working on. And then weeks 3 to 9, which is really the bulk of the course, is where students are exploring and analyzing the data. And then the last sort of like couple weeks, weeks 10 to 12 of the course is where students are giving their final project presentations and also their handover. So in terms of pre-course choosing partners and projects, the goals here are really to identify and connect with community partners and also do some initial project scoping. So in doing that project scoping, some of the things to consider is how available is the partner. This course really works well if partners are able to meet on a weekly basis with students. You're also looking at the scope of the project. So is it something that there's a part of an analysis that could be completed within the time frame? Does it match what students' background and interests are in? Are there going to be any issues with data access and privacy? Is the data there? Is it, you know, in a state where it, you know, won't be sort of spending the whole of the time on data cleaning? Are there going to be any issues or any sensitivities with the data that might mean you either need to get someone else from your university involved to help you create a secure environment, or it might mean that maybe another project could be more suitable. And then lastly, you're looking at the type of data and analysis. Is it going to build on students' prior knowledge and give them an opportunity to apply the I guess the sort of subject knowledge that they've developed and also the methodologies that they've had practice with. So then in phase 1, after you've sort of met with the partners and designed and set expectations, is the project planning and scoping. And this is where students are identifying key project milestones. They're going to be brainstorming ideas and approaches, and they're also planning project tasks. And so some of these can build on sort of gaining skills and asking relevant research questions, looking at sort of team members' backgrounds and their skill set. So in the course I taught, students came from a variety of different majors. Some were majoring in gender studies, some were majoring in economics, And those sort of backgrounds also can be really valuable and add to the technical skills that they have. And this is also where you're introducing some of the project management tasks that students are less familiar with. So after you've met with the partner to understand their goals and questions, students are also going to be setting goals for collaboration. And this involves creating a team contract where students are looking at what their personal and also group goals are for the project, how often they want to communicate, what their expectations are for one another during the course. And they're also going to be setting personal and team goals here. And these are similar to a professional development plan that students may sort of go into in the future when they're working as part of a team. But it allows them to take sort of control over their learning and identify what the areas they want to improve in. And these goals are guided by SMART principles, so they need to be specific, measurable, attainable within the time frame, relevant to the project. So for instance, kind of applying a convolution neural network, if the data set only has like 100 observations and actually isn't related to the question that they're looking at, isn't going to be sort of a relevant goal. And these goals also want to be time-based. So it gives students a chance to sort of reflect on what they know, reflect on what they'd like to develop, and what they're interested in. And they identified 3 goals and areas where they would like to improve. Phase 2 is about exploring and analyzing the data, and different from sort of previous projects that students might be familiar with, where you plan, create, review, and do a final release, final outcome. This uses agile methodologies where students are trying to plan, create, review, and release on a shorter time frame, where they can get feedback from their partners, participate in more knowledge exchange, more questions, and also make adjustments and get feedback as to whether the project they're developing is moving in the direction that the community partner is interested in. And we call each of these sort of small iterations a sprint, and a sprint could be sort of anywhere from 1 week, where it's culminating in a presentation to community partners, to something spread over 2 weeks, depending on sort of how often students are meeting and how many hours they're able to dedicate to the project if they're doing it alongside other courses. So what this looked like in my course was students would make a plan for what their goal was, what tasks they would be working on during the week on a Monday. This would then culminate in presentations, informal presentations to their partner on a Thursday. And it would be a chance to get feedback and also, try to sort of complete a small iteration of the project. And then lastly, the students produce a final presentation and final write-up, and also a handover where they're also documenting and presenting the code. This is ideally sort of something that they're doing along the way because it can take a lot of time. And then we're also building in time for feedback and revisions so that students can also, get a high quality product out to partners. In terms of reflections and advice after teaching this course, you definitely want to connect with your partners early because the data and the planning takes some time. Students also had best success with projects that were clearly defined and where partners were available. So where they could get feedback, where there was a clear goal in mind, was something that was extremely helpful. If you do have students with different backgrounds, additional tutorials can be a good way to support students with different technical backgrounds. It's also one of these things that applying knowledge and working on a project is really valuable, but it can be scary for students initially if they're not familiar already with some of the coding techniques. And I think it's really important to build reflection into the process. So project challenges are teaching moments. And there are also things that students can reference in later job interviews about how they dealt with sort of something unexpected along the way. And they're going to be sort of, more realistic in terms of what students might encounter in the real world. So thank you very much. Muchísimas gracias. Muito obrigada. I would like to thank so many people on this slide who helped make this presentation and course possible, including colleagues at Bates, the Turing Way and the Alan Turing Institute, and also the community partners.